We have previously talked about the slope of a straight line. If you have a straight line, you can write it like this. And here A is the slope. So for this curve, the slope is greater than 0. Here the slope is equal to 0. And here is a negative slope. So if you go one step in the x direction, the slope is how much you have to go up or down in the y direction to follow the line. But then how about a curve that is not straight? Can you talk about the slope here? Then you see that the slope depends on where on the curve you are. So it does not have the same slope at every point. But if we zoom in on the curve, then the curve looks like a straight line. So if you just zoom in close enough on the curve, it looks like a straight line. So locally we could talk about the slope. And this is the definition of the derivative. The derivative means the local slope of a curve. But you have to zoom in infinitely close to the curve. Otherwise the approximation that is a straight line will not hold. For a straight line we can calculate the slope given 2 points as y2 minus y1 divided by x2 minus x1. And here x2 minus x1 is this distance and y2 minus y1 is this distance. So if we go this many steps in the x direction, then we go this many steps in the y direction. If we divide this one with this one, then we find out how many steps we go in the y direction when we go one step in the x direction. That is the slope of the curve. So in this way we can calculate the local slope of any curve. And another name for local slope is derivative. So derivative means local slope of a curve. And that means that there are infinitely many different slopes here, depending on where we are. So different points have different local slopes. And this straight line here can be approximated by a tangent. So for example, in this point here, the slope of the tangent gives the local slope. And we see that different points have different local slopes. To a function f of x, there corresponds some curve here. And these 2 points we can calculate in the following way. So the first point will take the x coordinate of that, call it x. Then the y coordinate of that we call f of x. And this distance here we call h. So that's the distance between these 2 points along the x-axis. So there's a difference in x coordinate. And that means that this point here has an x coordinate of x, this x coordinate plus h. And then the function value for this point is f of this x, f of x plus h. Then we can calculate the local slope. So we take y2, which is this one. And then we subtract y1, which is this one. And x2 is equal to this. Minus x1, which is equal to x. So this is the local slope, which can be simplified to now we want to zoom in infinitely close. Otherwise our approximation of a straight line will not be perfect. So now we want to take the limit of this one when h goes to 0. So when this distance becomes smaller and smaller, that means that we are zooming in closer and closer. So we need to take the limit here. Then this is the local slope, and that is what we call the derivative. And the use of symbol for derivative is this one. You write the function with a prime. So this is the symbol for the derivative. So per definition this means this. So the derivative is defined in this way. And then derivative means local slope.